What's up, everybody? Howdy. My name is Mike Geig, and welcome to a Unity live stream. Today, we're going to be talking about dots. We're going to do some questions and answers with some of the folks from the dots team. But first, I believe we've got a video to watch. So before we hit introductions, let's check out that video.
Ask your questions about your dreams and memories.
All right. Well, high energy video there. Hopefully everyone's amped. I'm checking out the chat here, and everyone's who's saying hi. Hello back. How you doing? So I am joined here by two experts in dots. By the way, the data-oriented technology stack, dots. So we're joined here by Christopher and Daniel. Howdy, Christopher and Daniel. Christopher, why don't you start by introducing yourself?
All right. Well, yeah, I'm Christopher. I'm an engineer on the tech lead team in Dots. Been at Unity for like 6 years, used Unity for like 6 years before that, and been in games for ever. But yeah, Dots is my like mega passion.
Right on. Daniel, you're up.
Yeah, I mean, I don't have quite the same amount of experience as he does, but I am still on the Dots team, and I have been making a lot of the features that people use in Dots. I have been making games since I was 8 years old, learning Unity since I was 12, so I definitely know a lot about the field, and I'm glad to talk about Dots today, because it's one of my favorite subjects.
Fantastic. You know, one of these days we'll discover like the perfect way to just ease in one of these without it being slightly awkward. You know, not today,
Yeah.
but that's okay. Whatever. So today what we're going to be doing is we're going to be just basically answering a lot of questions, right? We've done live streams in the past and webinars and presentations. There's videos, there's ebooks, there's all these things. But we wanted to take, a day, some time to just rapid fire answer questions, right? So this is a great opportunity if you have any questions to pass them our way, but also I've got a whole list, even if you don't. And so that's what we're going to be doing. Now, throughout this entire live stream, I'm sure you'll be asking questions. I'm going to be doing my best to keep those questions, kind of organized. So we've got some categories we're going to be covering in order. So if you ask a question, earlier than we're at that category, trust that, we'll still get there, but we're going to try to keep it to these categories. That way we're not just sort of all over the place with concepts and things like that. So as you can see, we start with some icebreakers all the way through processing data, talk about some performance, platforms, all this stuff. So we have plenty to talk about today. Also, before we kind of dig into it, I did want to mention there's a ton of places you can go to learn about DOTS, or the data-oriented technology stack. We've got forums, we've got webinars, boot camps, we've got some great learn stuff. We're actually going to post those links here in the chat so that you can all see there. But you can see tons of stuff. Like I said, webinars, we've got great stuff on Unity to learn, the boot camps, the basics. We have a whole reading list. We have an ebook coming out, which is pretty cool. So it'd be good to pre-register for that, because those ebooks always have just so much information. And then coming up here next week on April 30th, we'll be doing an Odin Inspector, or just Odin, I don't even know if it's Inspector, live stream, including an update from the Asset Store Spring Sale. So that is April 30th at 12 Eastern. And then on May 1st, we're going to be talking a little bit about Unity Cloud Services and actually some of the tools you already have that you may not even know that you already have access to. So stay tuned for those. Those will be really cool as well. Sound good? I think that sounds good, right? Cool. Whatever. We're gonna go even if it doesn't sound good. It doesn't matter. So let's get into some icebreakers here. So basically, we just want to start with some real simple questions, maybe some fun while we wait for questions from the chat to start popping in and things like that. So my first question to both of you, and we'll start with Daniel. If dots were an animal, what animal would it be?
I've thought about this for a while. A herring.
A herring?
Which I got the suggestion from a coworker of mine. Because it's like, streamlined. It's this little fish. It's kind of niche if you want to eat it, but to those that like it, it's streamlined, fast, and you can have a lot of them, and that's kind of what dots is in a way.
Are you familiar with the phrase a red herring?
Well, it's not a red herring in this case.
I just wasn't sure if maybe that's where you're going with it.
No. In this case, it's just that they are niche, but they taste good, and they are very streamlined and fast.
Fair enough. I'm actually, someone in chat here said it's an octopus. Curious why they think that, but while we wait for that, Christopher, what about you?
My first thought was ant, or ants specifically. You're thinking about operating on like multiple thousands of entities, all working towards a common goal, all working in parallel. Like when I look at a job profiler and see dots used successfully, I see like the beautiful workings of an ant colony. And as an anecdote, I also thought, well, what if I asked ChatGPT what it would say for dots, and it also said ants. So my job has been surpassed, and I direct all questions to ChatGPT.
Next week, our live stream will be interviewing ChatGPT. I see Turbo Makes Games here in chat saying a cheetah, but I feel like that's kind of cheating because you already do a lot of dots content. So I feel like, and Daniel, don't you do live streams with Turbo Makes Games?
Yeah, I was about to say, I actually every week host a live stream with Johnny on data-oriented design, how to make games with dots, how do you make certain features, how do you make multiplayer, how do you make local split screen, all things dots. And his channel is great. If you want to learn more about dots, I can definitely recommend it.
There you go. What day do you normally stream on, or is it random?
It is Friday at 9 p.m. EST, Central Eastern
There you
time.
go.
Yeah.
You ever feel like Friday evening cracking open a cold one and watching some dot stuff with Daniel on Turbo? Then check that out.
Yeah.
Okay, so I mean that was kind of the more silly question, but given the longevity of us talking about these tools, when we originally started talking primarily about ECS, and over time that's evolved to dots. What is maybe the difference between ECS and dots? This is a softball question. I know it's very easy, but they're going to get harder. But what's this big difference here?
Shall I jump on that one?
Yeah, go for it.
All right. I would say dots is like, obviously it's in the name, like data-oriented tech stack. But like another way to look at it is dots is a kind of guiding principle on solving problems and building tools and technology to solve specific problems that are related to data at scale, and ECS is a central piece of that. But I think you could consider a lot of things to be dots. Like we talk about Burst and the job system and ECS, but I think you're in dots territory when you're just talking about like, I need to do a million things, like what's the most optimal way to do that. And maybe that isn't ECS. Like a lot of the times it is, but if it isn't and it's something else, like that is still dots, right? It's like the core principle of thinking about your data and what are you doing with your data and how to get the most out of it.
Right on. Daniel, anything to add, or was that perfect?
No, that was a great explanation. I mean, for me, a lot of the time, dots is also just about like, what is the simplest way that I can implement X, Y, Z? Like, what is the most efficient in terms of understanding as well? That way, it will often also be more performant. and
There
DOTS
you go.
really helps with that.
So, and that actually kind of plays nicely into my next question here, because you said the simplest way and the most efficient way, and I find that those two things are never the same thing. I mean, not never, but they're often not the same thing. And one of the things that I hear a lot from our users is like, do I have to unlearn object-oriented design or object-oriented programming to do data-oriented design, which is the foundation of dots, right? Like, I find this so hard because I'm so used to this other thing. Do I have to completely rewire my brain or rethink about all these problems? I have my own opinions on that, but actually, Daniel, what do you think?
I mean, generally, I think there's like a balance that you have to strike. Object-oriented programming is definitely something that most universities already teach, and data-oriented design is as if you hadn't gotten that knowledge to begin with, UML diagrams, all of it, and you just focus on making a thing. In that way, it can be more simple. It can also be more hard if you focus too much on getting everything to be the most efficient. It's always about striking a balance, but it's about trying not to force yourself into these big abstraction layers. And a lot of the times, that's what DOTS is about.
Christopher, anything to add?
Yeah, I often see the like OO versus DoD thing in conversations online and stuff. But in like the context of Unity, I would challenge the idea that coming from normal game objects to ECS, that you're having to unlearn some object-oriented way of thinking and relearn a data-oriented way of thinking. Game objects are already not object-oriented. You are doing composition with monobehaviors and components on a game object, right? You are not creating big, deep inheritance trees of something that's like base actor, and then inherit from that player actor, then inherit from that like server player actor. Like that is not Unity. So I would say if you're already thinking in a Unity way, you're much closer than ECS than you may realize.
Yeah. I mean, the relation to kind of look at in our version is just a game object is really just an entity component. And then in ECS, it would be there is a system. And, the system is your mono behavior. It kind of combines the component with the system as ECS pulls them apart.
Yep.
There you go. So I'm waiting for the news articles tomorrow morning. Unity is not object-oriented. And maybe. By the way, a couple questions from the chat here. Is this pre-recorded? No, it's not pre-recorded. You can tell because of the fact that I'm now responding to your question. But it is being recorded, so it will be available on demand afterwards. And then other people are in the chat discussing cache hits versus cache misses, which we can talk a little bit more about here shortly. Cool. So then last one, kind of in this simpler, icebreaker category here. What's the most interesting dots use case you've ever seen? Ooh.
I have one.
Okay, awesome.
It'll give Daniel time to like think of a better one than what I've got. This is a little weird one because it's like I think we often talk about dots in terms of I'm making a dots game, and so I write all my code for dots, and it's a hugely scalable game. But what I found the most interesting use case was a normal Unity game, not using game objects. They're making it was some kind of like a city simulation thing on a phone, right? But most of their gameplay was like a few objects. So like, why would you use ECS in this scenario? But what they did have was an incredible amount of things that like streamed in and out in the background and like around where the player interaction was happening. So they opted to use dots and ECS and subscenes to stream in and out this static data like much more efficiently than they ever could have done with game objects on a phone. And in a sense, we're not writing a dots game at all, but use the technology, like in my opinion, like very correctly to target a specific bottleneck they had, and allowed it to actually work on a phone.
Nice.
Yeah.
I
think I'll just pick a more like classic example, which is, city skyline, a big city, lots of simulation. There was some problem with graphics, but for the most part, all of the simulation is so fast. All of the interaction between little characters in your game, all of the little city simulation, water simulation, building mechanics, all of that, being able to query easily for it. And also, like, if you look at a game like Stun Duck, that has a whole authoring workflow that lets them quickly pull out all of the terrain materials, all of the wood, all of the trees in their game, and it will place it on the terrain. And it's baked into the subscene so they can quickly stream it in as quick as possible.
Yeah, that
Nice.
that last one's great. There was actually a stream of that, right? Like where they walked over like how their whole tooling worked that they did on Twitch. That was fantastic.
Right on. Cool. By the way, folks in the chat here, and I missed who just said it, but someone was like, well, maybe the questions are staged. And we do have questions written down that we're answering, though once questions start coming in chat, and there are a few, and we will respond to them when we get to the areas. We are taking questions. So don't think I don't see them. If I don't address them immediately, it's because, like, we're just waiting to get a little further on. I did see one, though, from Doron Guita. I don't know. Maybe that's how you say it. Asking about, hey, if each of these data components needs to be in its own file, all of a sudden there's all these files, right, in your project, which is not the case. You could put many component data structs in a singular file to avoid that very issue. I tend to put things in separate files because I'm ridiculous like that, and it doesn't really matter, how many files you have, but that's not a good way to do it. So don't listen to me on that one. So there you go. And then, a few other questions. We'll make sure we get to them. Sorry, what were you saying?
No, I was just going to add to that, which is that I always just tend to put initially the types in the same place that they're being used in the systems. And then they can be the same folders as the systems that they're being used by. And then you can start, if they're used by more, then move them elsewhere. But see as your project progresses.
Nice. And Liberator has confirmed on Twitch that he's going to Twitter to tell everyone that Unity is not object oriented. So
awesome.
What have we done? All right. Actually, I do want to add a dots use case that really stuck with me, and I'm probably going to butcher the hell out of this, so I'm really sorry. But I remember interviewing the Hard Space Shipbreaker folks back when we did our podcast for that season, the Unity Behind the Game. And what was really neat about that one is it was a dots use case that wasn't about like runtime with the players, like all this. I mean, they did use dots for a lot of that stuff, but the use case was specifically how they assembled the ships in the editor and used dots to improve their editor workflows, which I used to be a tools creator and stuff like that. I love making little tools and stuff. And so anything that make editor workflows more efficient is just like super duper cool. And they reduced the times of like their shipbuilding by some insane amount. So it's a really neat, use case. There we go. Cool.
Yeah. I also just remembered another good use case I saw, which is that now because dots is all for the most part written in C#, you can also have source access and you can actually modify the things you see and you can actually read the code that you want to be able to change. And I know Stun Duck uses this fact for a very specific reason, and there's a talk about it on this channel.
Nice. Cool. All right. Well, we have a couple of questions in the chat about like physics and a few other things, so we're definitely going to get to those when we kind of get to later sections. So don't think we don't see you there. Let's see here. Actually, here's a question that we can start off. Maybe it's too early. This is Sulaimor. Man, your names, I just can't. Maybe it's too early to ask this, but I'm wondering if there are any plans to revamp or upgrade the documentation. Anything you know of?
This is, I feel like documentation is something that we just must always remain vigilant with. It's so easy to commit code and then documentation is no longer up to date. It's but yes, I think we consider documentation a part of like what we call our definition of done when we complete a feature. So I think we should always be staying on top of it. And I welcome that if there's something you find missing in the documentation or incorrect, like please report it, post about it on the forums. Like we take reports about that very seriously. So
Yeah, I mean, documentation faults are as much of a bug issue as anything else.
Yes.
True. We have someone in chat called Null Exception who's complaining that we're always trying to get rid of them. So,
It's very true.
so there you go. All right, so let's hop into some meatier questions. So let's get into the creating entities section of this stream here. And again, we're going to try to cover things in the sections as much as we can. So at this point, let's do some questions around creating entities. So to kick things off here, what's baking? You know, the terms for these things have changed so much over the years, and the latest term is baking. So what is that?
All right, I guess I'll take that one. Okay, so if any of you were around when ECS was like super early and public, we used to have a feature called conversion, and it was doing in many ways the same thing baking does today, but it had performance issues, it had design issues that like didn't really meet our standards for scalability and safety, particularly around if you were making changes, and it wasn't picking them up super well. So if you remember that is what baking is. If you don't know what any of these things are, imagine you open the Unity editor up and you create a game object and you edit values on it, right? What happens there is that like we save a scene file that has a game object, you press play, we have that scene file loaded, and off you go. With dots, we didn't have this built into the editor initially. We needed a way to actually produce ECS data that you could still load. Because if you have code on game objects that are creating your entities and setting up your entities, then every time you press play, every time you load a project up in like a player, you're paying a huge cost of like creating entities. So we needed a way to actually load entity data as well. But on top of that, we didn't want to just stop with like, oh, well, okay, we create some entities and you can load those. We actually wanted to take it further, make the file formats like much more efficient so we can stream in enormous amounts of entities, which is how we're able to do things like Megacity, right? And all these large buildings and complex structures. But we also wanted to make it so that you could do more with the data than just one-to-one. In Unity, you have some value on your game object and you press play, you have the same value. It's like one-to-one mapping. But often you do a more complicated Unity game and things are not so simple. You typically have data that makes sense when you're editing and you're authoring something, and then you have data that makes sense when you're actually running your simulation. So this is the third thing we wanted to tackle, was we wanted to give an actual process for you to transform your information, your data, into something that is more practical, more optimal for runtime. So when we put all these three components together, baking is what we have as a result. So it's like one part a necessity at the moment to edit and create entities in the editor directly that are saved. And then it's two parts producing highly efficient entity binary files that we can stream in, as well as offering you a very robust transformation tool to convert your data, or bake your data as we call it, into something more suitable for runtime.
Yeah, and one of the great things that I've seen users like realize about this is just, hey, now I can actually go into play mode, I can change my little authoring objects, and they will actually get saved back. You don't have to, have the, oh no, I am in play mode, I changed all these values, and they won't get saved when I exit play mode. You don't have that. You have a separation of authoring and runtime, and they actually work for you, not against you.
Nice. We had a question here, Pluto, or Pluto, because there's two T's, so I don't know if it's Pluto or not, has asked if there's a way to bake or convert a game object like at runtime, like if you didn't want to use a subscene.
No. And there's a couple of reasons for that. The first is that's just doing the thing I said that people want to avoid, where imagine you have on start of your game, your mono behavior, and then you just start calling entities code like create and add component. That you can do that, right? So if you want to take some data and translate it to entities, you can do it that way. You will pay the price that every time you press play, if you have 100,000 of those, you're going to do 100,000 calls to create an entity, 100,000 calls to add a component, right? So if you go through baking, you actually can just stream this pre-made from disk very, very fast. And like when I say fast, I mean like thousands of times faster than you can load at game object scene. Like it's crazy different. So you missed that. So this is like reason one, you don't want to do it that way. And then reason two is, you know, this is all like, imagine you actually impose this in your game, right? Then when you ship this to every user out there, every player you have on Steam, like they're open your games. Like every time I open this game, why does it take like 2 minutes to load? Like, because you're spending all this time creating, converting data that you could have just done offline, right? So I think to come back to the question, I think the question is kind of, it's missing a piece maybe. And I would love to hear maybe a follow-up question, which is like, why do you feel like you want to bake something at runtime?
Why not? Though I will offer up that there are ways that you can manually create entities, right? And you can manually set up the data and things. It's not the same as baking, right? So there are things you can do at runtime. Plus, since you have access to like the source through programming, all things are possible. Yeah. But that would be entirely up to you to create at that point. Cool. All right. Oh, you were going to say something, Chris?
I could probably clarify. Like, baking is, unless you do these things, but like baking is also a huge stack of technology that is making all of this stuff work with like our build tools, the build pipeline. We automatically cache bake results, right? So, you know, when you make like a small change in like a large scene, baking is like heavily optimized to only do like apply that small change, right? And then it has like all kinds of features that allow it to detect that you're making incremental changes, and so it like minimizes the work. Whereas if you do this at runtime, like there's no tooling to manage this, and we wouldn't want to impose this tooling at runtime. Like there's a lot of stuff in Unity Engine that is turned off and stripped out when you actually make a player build, and it's just for performance reasons, it's for size reasons, and baking is a part of that. Baking is really like an asset and editor piece of the tooling, and not something you ever really want to do at runtime.
Like one can quickly imagine building out a huge game with a lot of different, like a whole city, and there are so many different armies going around. And how would you place those armies? How would you know all the generated content in that? Well, you could generate it live, but then it has a runtime cost all of a sudden, and it won't like show nice preview information, etc. Instead, if you just had a baking system that like breaks it all into the scene, then now you have something that's ready for runtime.
Right on. Sorry, I'm only kind of listening because I'm also reading through this chat here and trying to stay on top of all these questions.
No worries.
Oh man, and trying to add them to my list to where they belong. So sorry, everyone, if it looks like I'm not answering your questions or I'm skipping your questions. I'm not. I'm just frantically trying to put them into the sections where I feel like they go, so that we can answer them when we get there. So sorry about that. Okay, so perfect. So I guess follow-up question. And I think you already covered it, but like I said, I'm only kind of half paying attention here. When does baking happen? How can you be sure baking has happened?
Yeah, I didn't completely cover that, so that's a good follow-up. So baking is something that is tied to subscenes. Like right now, the only way for baking to happen is that you create a subscene and put your game object data in there. Then there's extra steps, you know, like we have these things called bakers where you define how you transform this data. And when you get these pieces right, then you're baking. then you're cooking. So when you have a subscene open and you have got bakers set up, it's happening automatically. As I'm editing and dragging things, we're doing what we call live baking. When you close the subscene, it actually does the bake in a background process and stores the cached result in the asset database, so in your library folder. And this cached result is what streams in really quick. So as like an example, say you're making a large world with like lots of buildings, like megacity style thing, you could have lots of subscenes defining all the different areas of your world. And if you only want to edit a small part of it, you know, you open this big scene and it's going to stream all of the content in really fast, right? Because it's all entities. But then you can just go open one subscene, and that's the expensive part. That's the game objects that you're editing right there. And this allows you to like just go and like do precision edits in this large world. Whereas if you imagine a world with like 1 million game objects at the moment, that's it's going to be awkward to deal with. So this is how you know it's happening. This is where you would use it, and that's the advantage you'd get out of it.
Nice. Michael J just said, why is there not a way to directly create entities like game objects and add components to it? But there is. You can actually do that for sure. So yeah.
I suppose the question
go ahead.
That maybe sorry to interrupt, but I guess
go for it.
The question could be like in the editor. And so that may be what they're wondering, because you're right. You definitely can do that at runtime in the code. But if the question is, why can't I just right click in my editor, create entity, add an iComponent data to it? The answer is mostly technical reasons that are like, there's a lot of plumbing to do in Unity, and it's it has a long history, and I agree that it should work that way. And all I would say is like, watch this space, because that is something that we're tackling.
And we already did announce at GDC that we are merging the concepts of game objects and entities a lot closer.
Mm-hmm.
So
fantastic. We'll get to that in the roadmap section too, because I have several people have been asking about that. Have been asking about this, like bringing these worlds closer and bridging between and stuff like that. So,
also, just to add to the previous question, I think another way to view baking is just simply, you can create an entity normally, but that can be a lot of boilerplate if you want mesh renderers, physics, and all of that set up for you. And baking just simplifies that workflow, so you don't have to create everything in code. So you have an authoring experience.
Nice. If anyone wants to see like a cool example of baking in action, like where you can segment out the game object to entity conversion process and like kind of just edit smaller parts of your scene, like Christopher was talking about, check out the new Mega City Metro. You can find it online. It has like all its lights are in one subscene, all its traffic is in one subscene, all these settings are in one. So it's cool. So you can just be like, I just want to edit a building, right? Cool. So I'll just open that one up, convert that entity to a game object, mess around with it, and then kind of convert it back, and without having to like have the heavy entire scene loaded at once. Also want to apologize to everyone in chat who thought we were going to be talking about baking, like with baked goods, breads and things like that. I've had a few people mention that. I'm sorry to mislead you. If you're on the East Coast like I am, it is lunchtime, so I'm sorry if I made you all hungry. But yeah. And someone's asking for a link to the Mega City Metro. I don't have it on hand. Sorry, we didn't preload that one. I probably should have. But if you just do a quick internet search for Mega City Metro, it'll be like literally the first thing that pops up. So sorry, I didn't have that one. Ready. Cool. All right. Had that question again from MH Rohan. Insights about transitioning from monobehavior based development to ECS and dots. We'll get there. That's down in my workflows section. So don't worry. Don't want to answer that one just yet. But don't think I didn't see you. So you guys have already answered my next question. Can you create entities without baking? Which we've already covered, that yes, you can use like an entity manager to instantiate an entity. You can use systems to instantiate an entity and then add data components to it manually through code. So we'll move on from that one. So, well, I think you've already covered this one too. The next question I had is, why do we structure it with like subscenes, right? Which you already talked about. But the second one is an actual workflow question. Is it important to close the subscenes when you're done using them, or like when you go into run mode or anything like that, or is it okay for them to be open?
Well, it's definitely okay, but you do pay a cost to having them open when you enter play mode, because we're keeping it in a state for live baking where it's not as optimized for streaming. So if you had the Mega City example, if you had like 15 buildings open and then you press play, you're not going to get the same streaming performance as you would otherwise.
And also, if we want to like visually show it, I actually have something on screen that we can show. That also, while you talk, can explain this.
I mean, well, you talk if you got it now. Like, go for it.
Yeah. Well, as he was saying, like the entire environment here doesn't have to be open if I'm just planning on changing my character around. in my little fun 2D game here. So because I have it closed now, whenever I enter play mode, it won't actually cause a rebake to happen. And it will stream in from the scene. And you can like unload it so you don't even have the visual feedback of what is happening there. Which is great if you have a big scene, because then it can add a bunch of clutter to both your level editing and all of, if you have a lot of graphic fidelity, like,
Fidelity.
high level of, fidelity. There you go. I was losing the word there. It will also cause your computer to slow down when you're editing stuff. So just being able to like close it out, not having it there, adds a lot. Yeah.
Right.
Obviously, we can load it back. And it's very quick to do so without causing a full rebake, which is happening there. Yes.
Cool. Thank you. Another question we get a lot is, do subscenes have any other purpose? Obviously, we use them, for the baking, right? But do they do anything else?
Well, there's the streaming side of it, I would say, is a big part of it. What we hook into subscenes is they become streamable units themselves. So you can actually leave them in your scene and they will just automatically stream. But if you do some more manual stuff, you can use subscenes as like pieces of a level that have logic to them. So in like a megacity metro example, like we don't just stream every building in, like we can stream stuff as you're flying around the level. So it's relevant. If you're making any kind of large world, I think this is a absolute must to be able to break it down in something that's manageable. And I would also add, it lets you separate your world into like uniquely authored bits. So you could imagine more people working on the same environment, but each person's taking like different sections of this big scene. And what's nice about this is that everyone can still edit and look at the large scene, because all the subscenes they're not editing are still being streamed in and displayed as pure entities, but they're editing like this, like, John's village, right? And he's in his little village and he's editing it. And someone else, Sarah, is over here and she's editing Sarah's village, and they can both submit these changes in their source control together without conflicting.
Yeah, and you don't even have to like mix it by region. Sometimes it can also just be nice to say all of the buildings are owned on their own subscene. That way, the person responsible for all the buildings in your game can actually edit them without causing conflict with the rest of the scene. Even though, it's not region based, you still have all the regions.
Yeah.
Cool. By the way, I like the little hand gesture you did when you said editing the village. It's like, was that 2 hammers maybe? Or just typing.
Mining away.
Fair enough. Couple more questions from chat here I'll answer real quick. So Slightly Esync says, what's the difference between subscenes and normal additive multi-scene architecture? So with multi-scene editing, we have those are actual scene files. They're Unity scenes, right? Subscenes used for baking are quite literally that. They are subscenes. They're a different type. They're basically they're a game object with a subscene component, are they not? Oh, Daniel went, oh,
you're peeking behind the curtain a little bit there, but yeah, that's...
Yeah, well, that is definitely true, partly, but the fact that it is a different scene is definitely not the case. A subscene is actually also just a normal scene. It's just... it's just a component.
Yes. There, in your project, there is a scene file that looks, if you just double click it, will look like any other game object scene. What's important is that when it's attached to a subscene game object, as you rightly point out, is a game object, then it will trigger the baking system and the entity serialization system, and it will produce what we call an artifact that is the thing we actually load. So while there is like a scene file on one hand, you end up with what we call an entity binary scene file on the other side.
Yeah, I can actually visualize that.
That is actually what you stream it.
Yeah, I can visualize that very quickly.
Cool.
Because, yeah, if he switches over to screen share. 1 second. No, wrong one.
Wrong one. Otherwise.
There we go. Beautiful.
Sweet.
Yeah.
Love the transition like slides over.
Yeah, that's beautiful. But yeah, so what we were talking about is the fact that I can actually, go in my project and find that very scene that is my game scene. And I think it's in here. Yeah. Then open it up as a normal scene, and everything is still here like a normal game object scene. But once it takes part of baking, then it, you put on this game object, you add the mono behavior subscene, and you put it there. That is actually what is causing that scene to bake and causing it to have like a proper entity scene file.
Yes.
Yeah.
Well, today I learned.
It's, I think, an important thing to point out with the whole baking process is there will never be game objects as a result of this. Like everything that isn't baked, it's like all discarded. And in the end, you will only get entities, which is what allows us to stream it in so fast.
And that's also why they don't have any name, because at runtime, names don't matter.
That feels like a tagline for some space sci-fi horror movie. At runtime, names don't matter. Right? Like in space, no one can hear you scream. Right? Yeah. Names don't matter. All right, I got one more question here in this section here. And I had someone ask me this last week, and I thought, all right, I'm going to ask this question. Why can't we just implement a system that lets Unity convert everything for us? Why do we have to do baking and create like authoring scripts and things like that?
I mean, even better, why doesn't Unity just know what you want to make and just produce it on screen for you? No. There are limits, right? Like, I think you could do some compelling stuff that we can do some automatic things, but you very quickly run into issues of like, what is the one-to-one relationship between these things? What do you actually need out of this? Does it make sense that this game object becomes one entity, or actually should it be 5 entities? Like do LODs get generated? Are they different entities? I think what's more compelling is that we enable you to directly edit and create entities in the editor, rather than try to move completely away from game objects forever. Game objects have their own unique value, and they work really well for things that cross-reference each other and stuff like that. So I think it's more important that you understand like the data you want to get in your game and how you want to use it, which goes back to the DOTS principles and DoD principles from before. It's like, know your data, right? And when something is magically changing your data into something else and you don't really know why, you definitely don't know what your data is doing at that point.
Fair enough. All I can think about is this Runtime movie now, starring Dwayne "The Rock" Johnson.
I'm so sorry.
In the trailer. So like, what time is it? And he goes, time to run, or whatever. But anyway, sorry, that's super cheesy. Okay, let's move on here. So our next section here is managing your data. So this is all about like data components and things like that. So basically, how, not just the conversion, right? But let's say we have our entities now. What are all these different types of data, pieces of data, and stuff like that? So you have questions around data and managing this data. Now is the time. And so the first question I have down here is, well, it's actually a many part question, because I kind of want to run through the different types of data components and just chat really quickly about what it does and when you would use it. Right. So the very first one here is just unmanaged data components, right? Is how we refer to it in our documentation. What is that, and when do you use it?
That is the vanilla straight ECS component right there. I think when you use that is when you don't have a good reason to use anything else. That is like the thing you should always go to. It enables the fastest path of everything, fastest serialization, fastest streaming, fastest processing. So without a really good reason to use anything else, stick to that one.
Cool. Sorry, just responding to someone in chat here. So then managed components.
So there's a whole there's almost an entire like semester of university behind the differences between a managed component and an unmanaged component. But without getting too far into that, needless to say, unmanaged is what lets us stay on the fast and happy path. Managed is when you have things where C# is runtime is controlling the object itself and like the memory of it, the lifetime of it, all these things, right? So when you have a class, when you have a string, these are managed, and they use like a reference system so things can point to each other very easily. Whereas unmanaged is really what we mean by that, and what that means in C# is value types. And that's where I could easily get into the details that you might learn in a computer science course. But needless to say, managed is when you can't avoid it. You need some way to have a reference to another managed thing. Like a game object is managed, a mono behavior is managed, a string is managed.
UI, animation, yeah.
Yes.
Yeah. And it's worth noting that if you do the managed stuff, you don't get the fun stuff, like the burst and things like that. So
Yes.
Exactly.
It's used with caution, basically.
Another
You'll
good
know it
point,
if you need it. What's
yeah,
that?
exactly.
Yeah.
And another good point to also think about is managed is like it will manage your data for you, but at the cost of performance. Unmanaged, you have to create stuff yourself and specify when you dispose it.
Fair enough. Fantastic. So next one here is shared components.
Okay, so in ECS, we have this concept of chunks. And the way they work is that, when we have an entity, we put it in a block of other entities that we call a chunk, and we put them as close together. You might think of this as like, if you know the term, structures of arrays, right? So each component of an entity occupies like an array in this chunk. I should have had a diagram that would have been perfect for this. But like, try to imagine my entity. I've got 4 components. Well, then they sit as individual rows in this chunk, right? And then we fit a fixed number of entities inside a chunk. And that's like the principle behind loads of the technology in ECS. It's how we process them. We always do it by chunk. When we serialize, we do it by chunk. Now, a shared component is a type of component that you can put on an entity that says every other entity with the same values in this shared component, I want to always be in the same chunk. And there's interesting reasons you might do that for performance. Like, let's say you are running jobs that process by chunk, and you want to process like one team, right? You got like different teams, like factions fighting each other. You could imagine a shared component where you put the team value on there. Then each team will always go in their own chunks. That way you can always process an entire team's chunk, knowing safely, or every entity in this chunk is always team A. That's kind of the gist of it. We also use it internally for a few ways to like filter things and put things in chunks.
I can actually show some of those in editor. Again, share screen.
There you go. And while you're doing that, I had someone ask, Tigrian had asked, what differentiates a managed shared component to an unmanaged shared component? They are both structs in the documentation.
Yes.
I believe managed is a class, is it not? Managed.
Yeah, no, they've rightly
No.
identified a tricky point in our API that I'm personally not a fan of, that we've done this, but yes, so if a struct in C# has managed fields, it is inherently managed. And so we allow shared components to be structs in both cases. And if one becomes managed because you've put a managed field in there, then it ends up on a different path. So of course, an unmanaged struct is faster, and that kind of guarantees, if you call it unmanaged, that's like, well, we're going to make sure that it follows the rules of being a managed struct, unmanaged struct.
An example of this is as a shared component, all things that are rendered in the engine actually share the same component, the same shared component that contains all of the managed references to the materials, the meshes, all of that, which is, default, class, objects. So they're all managed, and therefore, all of this shared component here has to be a managed shared component. Whereas if we look at the physics in the default physics setup, is we want all the physics to be that run in the same kind of logic to be in the same chunk. And that's why we have this thing called the physics world index. And it's just going to be one unmanaged shared component because it just stores an int. Nothing fancy here, no materials, no meshes. That's what an unmanaged shared component is.
Well, there you go. I'm looking at the clock here, and we're gonna move a little faster.
Yes.
We have so many questions. So let's moving quickly, but I still want to make sure we cover like the different component types. So a cleanup component.
Moving quickly. Okay.
Well,
when you destroy an entity and there's a cleanup component on it, it won't completely destroy the entity. It will destroy everything but that cleanup component. And the reason you want that is, say at the start of your game, you had your entity also create an animator, like a game object. Well, when that entity is destroyed, you also want to destroy that game object. So you just query for, hey, it no longer has all the other components on it, but it still has the cleanup component, and that cleanup component has a reference to the game object, so I'm going to destroy it. So therefore, it cleans up. That's really a lot
It's
of
like a
the point of
safety.
clean.
To just prevent something from being destroyed until you need it, until you tell it to be.
Yeah.
Exactly.
Cool. Tag components. Those always catch people because there's no such thing.
They're actually quite easy. It's just, you're right. There is no such thing. It's just a normal unmanaged component that has no values. And why might you use that? Well, if it's relevant to your queries, where you need something in the query that allows you to match to something that has this tag, but there's no values on it. So maybe the tag is like, this thing is burning. And okay, then this comes down the code path if it's on fire, that kind of thing.
Very techy.
There you go. Buffer components.
Yep. So sometimes we call them dynamic buffers as well. And essentially it's allows you to have like a equivalent of an array on an entity. Because in an iComponent data, you can't just put like an array that's managed. You can't put a native array because it's not safe with the job system. So a dynamic buffer is a way to have arrays of things on your entities while also still being safe for the job system.
Yeah, and the problem of native arrays is the classic, like, oh, now I need to dispose it also. So, yeah.
There you go. Okay. Chunk components. I feel like this is an academic challenge.
Chunk components. I would say a chunk component is something that probably almost no one would ever use. We use them internally. But to know the details, so internally for every chunk, we actually do create what we call a meta entity for the chunk. And that entity can have components put on it. And therefore that component is effectively associated with a chunk. And so this is a chunk component.
Yeah. And an example of where we use this is like world render bounds. We put some render bounds on certain objects and we consider all those chunks to be in the same bound just to batch up rendering.
A really advanced component. If you're finding yourself using it, you either have made a mistake or you're very clever.
Yeah. yes. That's a good way of saying it. And if you're very clever, here, there's probably a way that you could do something else that would work also.
Tom Trottle in chat says his head hurts, and it's like, yeah, basically for most of the time, like 99% of the time, your bread and butter is just going to be an unmanaged, a tag, maybe a singleton, which we're going to mention in a second. You know, a lot of these other ones, they only matter when you really, really dig into it. So I wouldn't worry so much about like internalizing all of this information. So two more, we're just going to get through real quick here. Enableable components.
So that is basically like a normal unmanaged iComponent data, but it has an additional state, which is enabled or not enabled. And this is useful where you want to have something like the tag, like the on fire tag, but you don't want to pay the price of a structural change by adding and removing it, because maybe your entity goes on fire and stops being on fire very often. I don't know what game you've made, but somehow this is happening in this example. And so you use an enableable component, which essentially would be like a tag, but you can toggle the state on it and still query for things based on, I need a query that is things that are on fire or things that are not on fire without the structural change.
Yeah. And a nice thing about that is also it can help you do batched destruction of things. And like, instead of having all your jobs trying to create a command buffer, quickly changing all this dynamic stuff, you just flip a little enableable component, and then at the very end, you do a query saying destroy everything that matches this condition. It's a very fast check.
Nice. By the way, do you all remember like Strong Bad's emails from Homestar Runner?
Oh,
Am I
yes.
too old? Okay. When
No,
you
but
said
he's
I'm
too young. There's
Yeah,
no way, Daniel.
yeah, no, I have
When
no
you-
idea.
I was thinking of the children's book when you said on fire, and I was just thinking of the no two people are not on fire, or the Trogdor. Like, what kind of game you're making? We're making a Burninator game. But anyway, way off topic there. But for you kids watching at home, and Daniel, who don't know Strong Bad's emails and Homestar Runner, and you want a relic of the internet, there you go. Check it out. Strong Bad's children's book, classic. That's where I
Okay,
learned
noted.
Fangoriously devoured
I
by a
have some
gelatinous
reading up to do
monster.
after.
And then the last one, again, is a bit of a tricky one. It's singleton components, which again don't exist.
Yeah, total misnomer. Singletons are really just, only one version of this component exists in this world. There's only one entity that has X component on it. When you do system_API.getSingleton or entityCore.getSingleton, it just asks to get that one entity that has that component, and then doesn't do any sort of job syncing or anything. It will just get it without syncing jobs. That's what it is. It's almost like saying, hey, I'm gonna do only get a single, and then no dependencies, job syncing, etc. So where this might be useful is like if you have like your audio manager, and you only wanna you just wanna find your UI system or your audio manager, and in your system, then you can do get singleton audio manager and then get that. Another case where we use this internally is like entity command buffer systems. That way you can create an entity command buffer for a specific system.
There you go. And they're not the same as like the singleton design pattern and object-oriented programming, which causes a lot of wars on the internet as to whether or not they're okay or not. So different type of singleton.
The name is definitely a misnomer. It's
yeah. I do have a question in chat from Crush Punch, who says, for a new project, would it be better to create functionality the traditional Unity way and then convert to dots, or just start with dots?
My go-to is, unless you have a very specific game that you think dots is the way to enable this game, if you're just prototyping and trying and playing, I would say go the traditional way.
I'm a firm believer of use dots when you need to use dots to solve an actual problem or a thing will be a problem. If you just like, I'm just going to do it just because it'll be funsies.
And also a good hint here is that a lot of the time, burst and jobs are enough. You can, like, if say you were making the next Minecraft and your chunk generation is extremely slow, well, okay, then take some of that chunk data, make it unmanaged, initially see if that helps performance. Sometimes that's enough. Then, oh, now I can put burst on it. Is that enough? Most time that's like a 10x boost. I once did a Minecraft clone that did this very trick, and it actually was 10 times faster just from that. And then you can put it in a job if you want.
Also, to be clear, he's talking about voxel chunks, not ECS chunks.
Yes, that's a good point. That's a very good point. Yes.
Yeah, there you go.
But yeah, the point is just like often you can just take a very specific feature in your game and then slowly start turning it unmanaged and burstable, and then see if a job is required. And when it is unmanaged already, making it a job is not that far away.
Cool. And then another question here from Juan Caher. I don't know, man. You guys and your names. I'm terrible at this. So can you actually manipulate a scriptable object via either entity, or job systems or jobs?
You can get data from one.
Yeah. I mean, a scriptable object is actually just a Unity asset. So I would say the same thing to, can you manipulate a texture in
So it is
ECS
managed then, just to clarify when you say that, what we're talking about. Yep.
Exactly. In fact, I would say it's slightly easier in Entities 1.2 because we now have this thing called Unity Object Ref, which allows you to have references to Unity assets on an iComponent data that's still unmanaged. Now, when you come to resolve it into the actual asset, you have to be in an unmanaged context, so it won't work in burst. But it means you can pass this around, like copy the values to other people. And it's really, really good if you want to reference like texture, material, sound, even a prefab. If you want to spawn like a game object prefab, you can have it referenced. And in this case, also a scriptable object.
Yeah, and you can even use the component for the most part with burst as long as you are not planning on using the actual value, actual managed data.
Yep.
There you go. Cool. All right. And then that gets us out of our like rapid fire data components section here. One last question in this section here. Why are there 2 transform data components? There is the local transform and local to world.
So in transforms, in transforms, like it's this huge field, but in game engines and games, like there is a difference between a local to world matrix, which is more important for rendering, and what we call a TRS, which is transform, rotation, and scale. And so the local transform is a TRS. It's like the position as a float 3, it's the rotation as like a quaternion, and the scale as another float 3. While the local to world is that turned into an actual matrix, which we need to upload to the shader for rendering and things like that.
There you go. Cool. Right on. So basically, it's just about having specialized data to do the thing that you need really fast without having to convert it each and every time.
Exactly. And I guess I could also add that primarily you should only be thinking about local to world. Local transform. Now I've just confused everyone. Local transform, the TRS, the simple thing is what you should interact with because we compose the final matrix. So you shouldn't be thinking about that in most cases.
And oftentimes it can also be good to know about the transform system group, which is something that you need to update the local transform before, because if you do it after, then the update to the local to world will already have happened. So it's very you have to make sure that you always do it before the transform system group, and then everything works and it's great.
Cool. All right. Well, great. Let's move on to the next section now, which is processing data. So now we've talked about the data components, but now we're going to talk about things like systems and ways for these things to work. So that's what we're going to move on to. So first thing here is, what is a system and how is it different from a model behavior or a job?
Well, Daniel, I feel like you covered this a little bit, so why don't you expand on it?
Yeah, I mean, the main difference is, like, if you look at a game object, the game object has a component on it, and every time that component, which is called a mono behavior, you always have the update as part of that component, right? So it's almost like a component is a component and a system. And when you are in ECS, it is just a system. You have your system and you write code that looks for certain objects and certain components. And then that is actually what incurs behavior. A lot of the time, it's also like, think about your game instead of gravity being, every object in your game, is because this object likes to fall down itself. No, it's more like this object here has a, mass, and because it has a mass, it will fall down. And the system would be the gravity system. It looks for everything that has a mass, and then it will fall down. Whereas in monobehavior land, it would be, the object itself that would move itself down. And that is also what makes it optimized. It's what enables us to have vectorization, loop over everything very fast, and yeah.
I feel like some unintentional product placement.
Yeah, I should have done this instead.
Or no, you should do like Vanna White, like just show it off.
I should
there.
charge money for this. That's
So, all right, at this point, kind of like what we did with the components, I kind of want to loop down through the different ways, through the different ways of editing or processing data to kind of get the when you would use one thing versus the other, right? And so the first one, and you see this every once in a while in more simpler code, is an entities.forEach loop. Like, where and when is that the right way to go?
So we have, I'm going to preempt another one you might get to, which is the idiomatic for each, something like that. Entities for each is an old approach we have to looping entity data that use source-gen and a bunch of other magic. We have now moved on to more of a split, because entities for each let you write some ECS code and you could either run it on the main thread or you could run it parallel least that was the theory, but through the early pre-release versions of entities, we regularly ran into this being very problematic. And we've since then implemented idiomatic for each and iJob entity as replacements for the case of entities for each. So I would actually answer the question by saying, don't use entities for each. It is not long for this world.
Yeah, another way of saying it is also entities for each often leads you to a false sense of security that, oh, I should always be using scheduled parallel. Scheduled parallel is also always the right option, even though you have like one entity or something. And you're like, well, yep, you don't need to schedule parallel your player loop. That doesn't make sense. It's actually more expensive than what you were going for. And so a lot of the time, it's system API query is enough, what he calls idiomatic for each. And there's so much hidden magic in an entities for each that we can't really recommend it. And it's also very slow for iteration time. It compiles slow. So it really hinders your workflow.
So, excuse me, I gotta go update the demo I just did last week. There's parts in it where I use it because I'm like, oh, this is easy.
Yeah. And I mean, the documentation also still needs some updating there. But
yeah, and it's also worth saying, like, it is in entities 1, 1.1, 1.2. Like, it's a fully supported feature. But in the same version of entities, there are what I would consider better alternatives these days.
Yeah. And actually, I have to check now. Now I'm not sure. I may not be using entities for each. I think I'm using the next one I'm about to mention here, which is the idiomatic for each.
Yes. So when to use that? That is when you want to do most things. So when Daniel mentions that like a mono behavior is like a component and a system combined, and then when you have a system, now you need to operate on not just one entity at a time, because the system is, I need to do the same set of operations. So if you imagine you have a mono behavior for like a car, and now you've duplicated this car 10 times, well, it's going to call update on that mono behavior 10 times. Instead of that, the system will call, like the car moving system will have one update, but inside that you need to loop the 10 cars. And so the idiomatic for each is what you'd go to when you want something the equivalent of a mono behavior update on your car, using idiomatic for each.
There's another added benefit, which is as long as you're on the main thread and not in a job, it is also allowed to use managed references. So you could get a static data, you can get your UI static somewhere, and you can actually use that in your for each without any problem. And you can even use the entity manager in there and cause additive structural changes like creating a new entity or instantiation or creating a new archetype. Those are all allowed in an idiomatic for each, and it's not in many of the other alternatives we'll soon talk about.
There you go. Why is it called idiomatic for each, by the way? Because that word idiomatic does not appear in how you use it, so it's just for each.
It's I guess we have a tendency to bleed terms that make sense internally and like externally. Yeah. And entities for each, the first one, was the first thing we had. And if you actually look at it, it's not a genuine C# for each. It might have the name, but actually it's a method call that takes a delegate, and then we call back the delegate for every entity. But that's not a real C# style for each. And so the idiomatic for each came born from the idea of like, well, let's support iterating entities, but in a way that actually uses normal C# features like a for each. So if you look at idiomatic for each, you're actually typing for each, and it's the C# keyword, and then you're filling in the fields. You
can actually use return and continue like you normally would be able to, which is something you couldn't before.
So it's idiomatic in that it is, well,
feels like C#.
Idiomatic.
Yeah, it feels like C#. It doesn't feel magic.
Yep.
Idiomatic magic.
I mean, I feel like it's all magic, right? Like if you keep your heart open, every day can be magic. Write that down. So the next is job.withCode.
Yeah, that's similar to entities for each, just for jobs instead. And again, the same recommendation can be set here, that you can just write a job instead. And that will often make more sense and be more customizable. And doesn't feel like as hidden magic, oh no, what's going to happen here?
Okay. Yeah. Then we have iJob chunk, which is not a system, right? You know, it's hard to write this section because some things go in systems and some things are jobs.
Yeah.
So iJob chunk is a job type.
I mean, yeah. Okay, I can explain
Go for
it. It's soon we'll talk about something called iJob entity. iJob
That's
chunk.
next.
Oh, great! It's iJob chunk is the main powerhouse behind it. It lets you loop over on a per chunk basis, really giving you the power of being able to control a whole chunk at a time, making batched operations, vectorization, all of that jazz. It's a lot more manual way to work with entities, but it's also a lot more powerful in what you can do. An iJob entity was actually written to be able to slowly move your way into that if you need it.
Yeah, I feel like iJob chunk is like your Swiss Army knife, so to speak. It's the bread and butter way of doing a lot of things, and leads us into the next one, which is iJob entity, which is maybe the more entry way to work with it.
Yeah, so the main problem with working with iJob chunk is just that you have to create all your chunk type handles yourself, all of your lookup types, and pass them in manually. And that can often, turn a lot of people away from using dots if they, have a hard time writing, oh, I just need to loop over a transform, I just need to loop over everything that has an entity, all of this like very normal entity behavior stuff. And an iJob entity is just something that allows to quickly generate a query that matches those components that you have in your execute, and all of it is scheduled, and you can do schedule parallel, and it will generate everything for you automatically, passing in those arguments to the execute. But really behind the scenes, it is just an iJob chunk.
Cool. Real quick question in chat from Guiu Alexandru about when is it recommended to use dots versus normal mono behaviors. We kind of covered this earlier, so I'll just say it real quick so you don't think we're not answering your question there. But basically, use mono behaviors until you need to use dots, until you find a problem that needs dot-specific capabilities, either performance-based or memory management or whatever to solve. A lot of your stuff will just be normal mono behaviors. I'm a big fan of hybrid, and we kind of go on from there. So hope that helps. And then the MetaMax says, I've always been scared to use iJob chunk. It's not bad. Plus, check out the webinar I did last week. The collision system is an iJob chunk in there if you want to see an example of it. Don't use the collision code. It's horrifyingly bad on purpose, but the structure of the iJob chunk is well done. So definitely check that out. Cool. And then
something I can also recommend is just looking at the generated code, because a lot of the time the generated code would tell you exactly how an iJob chunk should look. And Rider supports this, and there's a flag to enable it for VS Code and Visual Studio.
Well, there you go. Hopefully making it a little less scary. And so the last on this list here is like the iJob Parallel 4, which I remember even from back before using a lot, but it's not as common now, it seems.
Yeah, so iJob goes back to the job system part of ECS. That's just a normal job. And if we talk a lot about ECS when we talk about dots, but as was recommended earlier, like you could make a game that is just game objects, and you make a little use of bursts and a little use of jobs. So if you need to do any parallelism, like make use of your cores, asynchronous processing, but you're making a normal game object game, yeah, use an iJob, right? I recommend not using normal C# tasks and threads, because iJob is a feature we ship that works with burst and also works with our job scheduling system. So you're not going to compete with your cores with like the rest of Unity's own internal job behavior that's happening. So use iJob when you need jobs, regardless of whether or not you're using ECS.
Yeah. There's also another part of that question was also something called iJob 4 versus iJob Parallel 4. iJob Parallel 4 was like the first one to let you have an execute that loops over a set of items, whereas but it only is always going to be scheduled parallel. And iJob 4 is an iteration on that. It's the next API that lets you do schedule parallel, and run on main thread. So I can definitely recommend using that one over the old one. Yeah.
Well, there you go. Okay. So this is a chat that came from Bob Smith in chat, or a question that came from Bob Smith in chat. Can jobs call methods or functions for the sake of simplifying or reusing the code.
Static methods, yes.
Yes.
Struct methods, yes. But anything like a class, not really, unless you somehow got a class in a job. But then you can't use burst, obviously.
So like in the job struct itself, you could have methods to help you simplify your code and make it more readable.
Exactly. That you can totally do. Yeah.
Cool. There you go. But if that same method was a part of a member of a class, right, then you're getting into no good territories unless it's static. Only if it's static, or are there other requirements?
There needs to be if it's static and it's a static in a class, you can call it, because there's no actual managed object instance that exists there. It's just a function you're calling. It can matter if the parameters that you have to pass in are managed and things like that, or maybe it creates a managed object inside of it. Burst will tell you this is not acceptable. But if there's no managed object, that really is the rule, then Burst won't complain and you're good.
Yeah. Something important to tell here is also you don't need a job in order to do anything with Burst. You can just have a static method, and as long as the parameters are unmanaged, then you're good to go. Like you can burst that method and it will work, and it will call the bursted version.
There you go. I also just think that's a fun way to refer to it. We're going to burst that method, which sounds really cool.
Like bursting a bubble.
Exactly, right? Or a burst of energy. So the last question I have here. So we've seen this kind of written two ways. When you're scheduling a job, and in your system you read in like the state, and oftentimes you'll schedule the job by passing in state.dependency and then writing the return of state of that schedule to state.dependency. You could do it that way, or you could just not pass that in, not read it back or whatever. Which is the right way to do? Because I've seen it work both ways.
Almost always the right thing to do is pass in the state dependency. And that's because that's what hooks your job into our safety system a little more. So we kind of track a little bit of like what types are being read and written by various systems, and behind the scenes we're passing this state dependency along so that we can build more of a dependency graph so that the jobs run in the correct order. You know, if you have a previous system that's like, I'm going to be writing to this value, and then you have a system that comes after and it's like, oh, I'm going to be reading from it. If you don't pass in the state dependency, they will collide and you will get a runtime error saying, well, one job is writing to this while you're reading from it. But if you do pass in the state dependency, they will correctly make sure that they depend on each other, even though you didn't explicitly say these two jobs depend on each other. We've just done it behind the scenes for you because we have identified, oh, you're actually using the same types in these two jobs. And so we'll make sure they go in the right order.
It's basically like every system knows everything that goes in and out of it, but it only, the stored jobs for that system is only stored in state.dependency. And when the next system goes to read from that, in order to figure out which jobs to complete, it will need to, it is all inside the state.dependency. And iJob entity is the only case and entities for each. Both of those cases, you don't technically have to pass it in, but it feels sort of magic, so it can sometimes be good to do it still. And also it can be very, it can catch you off guard when you then forget to do it for iJob 4, where iJob 4 will pass in a default handle instead of state.dependency, and then you wonder why things are not completing correctly. So it can actually be good to do both, like pass it in. Always pass in state dependency. And then it's also important to assign it back to state dependency. So
right. You have to write it back so it can chain that. So actually, Chad Franklin in chat just asked, for example, if one system modifies component data, the next system that reads that data should wait on the first system, but does a system that reads component data cause a dependency? And I think that's kind of what you were just saying. By passing in the state dependency and by writing back to it, it helps the system, or however you want to refer to it. It helps the scheduler, maybe. I don't know. What's the name of it? Actually?
Dependency manager.
Yep.
The dependency manager helps the dependency manager keep that all in order and correct, right?
Yep.
Yes.
And in case people are wondering, like, we do have a distinction between read and write dependencies and read dependencies. So if you each system is just doing reads on the same type, one after the other, there will be no conflict, and our dependency manager will detect this and say, okay, we can just run these jobs whenever. It doesn't matter.
You can have a bunch of read dependencies, and only the write dependency later on will be the one that completes all of the read dependencies.
Exactly.
Right. So basically, by virtue of reading, you're not necessarily creating a dependency. Only if something is trying to access the data, or just write to the data that you're trying to read,
exactly.
sort of simultaneously. Fantastic. Cool. So let's move on here. We had a lot of questions come up in chat, and I've said later for our workflows section. So that is the section we are on now. So in the workflows section, we want to talk about hybrid stuff, the ways that you can accomplish certain things that maybe you're not quite sure about, basically all that goodness. And so the first question here comes from Liz Kimber in chat here. And it's, how does lighting work with entities? Well, first off, does lighting work with entities, like mono behavior lights, and then entity?
Yeah, so it does, but there's a variety of lighting scenarios, right? Like, if we're talking just normal runtime dynamic lights, yes, if you have a game object cube and you have if you have an entities cube and you have a game object runtime light, it will light that cube. Like that works. Additionally, the same will happen if you have baked lighting. Like, it can bake lighting information on subscene data that you have. So your static ECS data can also get baked lights. And then finally, we also support what's called a companion component, which is a little bit of a black magic piece of the pie, but it means that if you put a light in a subscene, we will do a little trickery to make sure that there's an entity at runtime that is associated with the light. So if you move this entity, it will move the light around.
A game object, but so specific components, when you add those in your subscene, it will make sure that there is also an attached game object to that has that actual component, and that is synced so that if you were to move your entity around, the game object also moves around. And if you were to destroy the entity, you also destroy the game object.
You said that's handled for you, the movement and the destruction and all that stuff?
Yep.
Yeah.
Called a companion object. There you go. By the way, for everyone here, some people in chat are saying they hear music. Are we playing background music? I don't hear any music. Okay, fair enough. A couple people have said that they hear music.
They're just loving what we're saying. It's like music to their ears.
Maybe it is.
A lot of people in chat are saying we're playing music. A lot of people now are responding, there's music. Oh.
Yeah, there is music. But again, we can't hear it. Yeah,
we just can't hear it. Oh. Yes.
Oh.
I'm sorry. I didn't.
Well, now I'm disappointed. I'm just sitting here and
music.
I thought they were talking about our voice.
Like angelic, right? A choir. Wow. All right. Then we can't hear it as the host. So sorry. I'm like, you're crazy. So there you go. Fair enough. Sorry. I don't know how it's playing, so I don't know how to turn it down for the folks who originally said that. Fair enough. There's something in the water. You're all hearing music. Okay. Well, thanks for that. So another question here is basically, how do you tell if an entity exists? And also, like, it's common that people want to be like, I want to work on that entity because they're used to doing that with like game objects. What would you say about like, how do you manage that? So I guess that's a two-parter. How to know even if a game or an entity exists, and then how to be like, I want this entity.
Well, it depends what you mean by if it exists. Like, there's a function in Entity Manager called exists, and you can pass in an entity and it will tell you yes or no. But maybe the question is like, does a certain kind of entity exist, right? Like, people often in game objects do game object.find with a name, or they look for like a special tag, that kind of thing. Maybe you're like trying to find a camera, right? I guess there's a couple parts to it. Like, first, if you're doing game object.find, don't do that. That's not very good, even for game objects. And often the solution there is that you bind it. So you drag the thing you care about into a field on a mono behavior, and then that's how you access it. And I bring that up because I would recommend the same thing with entities. If you're using baking and subscenes, if you care about a certain entity, you can, in baking, actually bind the result of a bake so that you can reference another one directly. So maybe you've got something following something else, you can plug them together, and then at runtime, you've got an entity field. So that's one way. And another way is actually use a query. Understand the types on this entity specifically and define a query for it. And then from that query, you can get any entities that are matching that query.
Yeah. So for anyone that's used to doing game object, find object of type, that one is technically very slow compared to when you do a query looking for a specific type. Like get singleton is actually, a way faster approach to that.
All right, there you go. Sorry, just responding to someone in chat here. And then, okay, fantastic. And then, so when would you use /avoid entity command buffers? Or maybe first, what is an entity command buffer? And then when would you use them or avoid them?
So an entity command buffer is just a way to defer any structural changes. So when you want to modify how many components are in an entity, how many, what shared component is it? Because as we talked about earlier, a shared component has to do with the chunk itself. So therefore, changing a value in it would change the structure of it. Anytime you want to do that sort of action, well, on the main thread, you can. And it's often faster to do it on the main thread through the entity manager. But if you are in a job, that's not an option. And that's where you want to defer the actions. So you just store them to be played back later. Yeah. And when do you use one or the other? I mean, generally, if you can use the entity manager, it's often faster. But it's not always possible. And sometimes you're also trying to just like, you're not planning on having a bunch of commands being played back. And so it's often also easier to just, I'm just going to have an entity command buffer that is played back after I'm moving over things.
There you go. Yeah, like, again, the webinar I did last week, I'm plugging my own project, whatever you want to check it out. But basically, if you need to like iterate over a bunch of entities and be like, it's time for you to die, I can't just destroy it. You can't destroy it right there in the loop. That invalidates the structure, right? So you have to be like, let's wait until after the loop, and then we'll destroy all these ones. So the entity command buffer allows you to like insert those commands and then play them back later and destroy them.
And as I also said earlier, you can also just switch an enableable component and then later on have something query for it and destroy everything with that query, which is technically faster. Also, to plug myself there, Johnny and I have a little short clip on that. You can just go on YouTube searching why use entity command buffers.
There you go. Fantastic. All right. And then a question from Rage Run Games. Will it be much easier in the future to mix game objects with entities?
Yes, 100%.
Yeah.
If only I could show you some of the cool stuff that you can do now. It's watch this space. I can't wait to show it off one day.
There's a lot of cool stuff coming. Yeah. But soon. Right on. Okay, fair enough. One other question we had, and this was from a previous one, and not from chat here, but how would you recommend doing like some common mechanics like one frame events, like triggers or things like that with ECS specifically?
Well, the most common approach people take is that they have a tag and they have queries that respond to them. Like you mentioned the destroying something, like as Daniel said, you could actually have an enabled bit or a tag or something, and you could have a query later that responds to it. So if you imagine early on in your frame, a system is saying, this thing's health has reached 0. Okay, so we add a tag to it that says destroyed. And then later in the frame, there's a system that's querying for anything with destroyed and then deleting the entity. So that is essentially like a once at a time kind of interaction. I wouldn't recommend doing that if it happens a lot and using tags that you add and remove. You could certainly use enabled components to make that much faster. I also would recommend that just consider something else. Like you don't have to necessarily go via entities. It really depends on like what is your performance bottleneck? How often is this happening? I know that's an easy answer. Like it depends, I probably could say it depends to almost every question that gets asked about should I do this or that? It depends.
That's a very dots way of thinking as well. Like any dots scenario is always, look at the data, look at why it's there. That is why we always say it depends. And polling,
with dots,
by the way,
I say it depends more than anything else. Yeah, what is it you're actually trying to do? Yeah, because there's a lot of ways to accomplish the same thing.
And another classic approach to events in dots is also just polling, like, oh, I'm just gonna check every frame if this value is, true or false now. And that can be very good if it's like something that you expect to be highly dynamic. It changes every frame, and you don't know how much or how little.
There you go. Okay. So let's quickly chat real quick here about performance. There's only a couple questions in here, and then roadmap comes after that, which is, where a lot of the questions have been popping up in chat and things like that. So with performance here, so what is burst? What is it doing? I know we talked a little bit about the requirements, and we know kind of like what happens when you use it, but what is it?
So technically burst is a compiler that we ship. And what it's doing is that it's taking small parts of your C# and it's compiling it into native code. And then we do some little bit of magic so that when you call your C# that's bursted, it's actually calling this native code instead. But the real magic sauce of that is that burst is doing tailored optimizations. Like it can insert intrinsics, or it can like discover optimizations that you could do that the normal C# compiler cannot do. And the reason we can do specific optimizations is because burst has hard constraints on the types of C# you're allowed to use. There's actually quite a nice blog post about this that Unity put out some years back called HPC#, which I think is high performance C#. And it kind of goes over the details of like what is the restriction burst has on C# that enables this performance. Like what limits do you have? And this mostly is where you'll get into topics of like splittable types, basic types, unmanaged types, why managed isn't good, and like not aliasing, things like that. It's a whole rabbit hole of fascinating stuff if you're really into performance.
Awesome. By the way, real quick here, Lockyaw says, Daniel, nice lighting. So well done. You win
I also
the
don't
lighting
control.
trophy.
I'm glad he says so. I don't control the lighting. It's called the sun.
There you go. And then we had another question. Bob Smith, and then MetaMax. I'm going to get to you. You're next. But Bob Smith here brought up that we said don't use dots unless you're trying to solve a problem, right? Like unless you need to. Is that because of the state of dots, like because it's not complete or not functional or whatever, or is it by design? The dots is made for specific tasks, or what do we mean by that?
There's a little bit of the first one, and I would say that because dots has tailored initially towards like high performant cases, and like I'm not going to pretend the workflow is as perfect as game objects are today, like very basic, and we are addressing that. So from that point of view, yeah, there's a little bit more pain to get into dots. So like consider that when you're thinking, well, I want to use this. So make sure it's worth that little bit of extra like boilerplate and typing and getting around the bush to get to your outcome. All that said though, I think there are good reasons to use dots that aren't necessarily performance. I think dots is a really good place. There's a lot of people using it. There's a lot of games out there on Steam that are doing phenomenal things because of dots. And so it's not in a bad state at all for that stuff. And there's also a lot of people who use dots because they really like the style of coding. Like there are principles behind dots that are quite interesting. For example, that the way systems work, you're querying types. So you don't have these like concrete binding. It's something more like a data protocol, like things that match this data type I want to operate on. And so you can imagine a big complex game, right? And all these things are happening to all your entities. You've been working this game for 5 years and you think, well, I want to just add in one new state to my object to my entity and I want to process it. If you have a big, complex, normal Unity game, you're adding another if statement in like a giant update loop of your model behavior. It's complicated, it's messy. In ECS, you just create a new system that queries for the exact scenario you care about, and you add your code right there. It just automatically inserts. It's an elegance to it.
Yeah, it sort of adds a lot of composability to it, because you can just like add all these systems just acting upon your world. It like really enables, if anyone has ever learned about systemic gameplay, where all the little systems in your game play together to make a new mechanic, it sort of, enables a very easy way to program that sort of scenario. There is a, strong cost in learning dots initially, and also setting up the project, understanding the camera, UI, how you do everything that dots can currently not do. But once you have built a certain size of project, it actually gets easier over time. It gets more flexible. It gets easier to refactor as well. So there's like some cost loss benefit here, but there's more to dots than just performance.
There you go. This is true. Also, yeah, I mean, besides just pure performance, right? There's a lot of tangential benefits, as mentioned, in terms of development stuff. But a lot of times people think performance means I can just crank it to 11, but sometimes it just means performance for performance sake, like using less battery, generating less heat. If you're working with mobile and things like that, it doesn't have to be like push everything to the max, right? I mean, that's what I tend to do because why not? It's fun, but that doesn't mean you have to. So, all right. So MetaMax has asked a question in chat here. Basically, what are structural changes? Why are they so bad? Are they sometimes okay? Oh, I'm paraphrasing, by the way. That wasn't the exact question.
Okay, so a structural change is essentially when you are causing movement of data in ECS. And that's a little specific, but there are scenarios that cause this. If I destroy an entity, we have to find the entity and its data in chunks and then delete it, and then adjust the chunk along so that everything is tightly packed together. That's a structural change. If you add a new type of component to an entity, it cannot sit in a chunk that is with entities of different types. So we need to move it to a chunk that matches the same, what we call archetype. So archetype is just, I am this set of types that defines my entity. So these are structural changes, and they cause entities to move around in memory and component data. They're bad primarily for two reasons. One, if you do that a lot, moving memory around has a cost. So you just have to be mindful that has a cost, particularly on some devices that, just are slower, right? If you're on a phone, it might be more expensive to move memory around a lot. The other reason it's really bad is that it forces currently scheduled and running jobs to synchronize. Because if we are about to move data around, similar to the read-write case we were talking about before, moving data around is essentially a write. So anything that's running has to be completed at that point, which means everything after that structural change that you might have done and used that CPU time no longer is running those jobs. So this is like the two real big reasons to avoid it. And I think you said, is it sometimes okay? It depends. Yes, it is. You have to understand like what's the performance profile of your game, and maybe all your job work is done, and then you can do some structural change at the end of the frame. And also, you can avoid it. You're going to have to delete an entity. You're going to have to create an entity. It's likely you're going to have to modify an entity structure. So don't sweat it if you're doing it. Just be mindful of how much you might be doing it.
Yeah, it's basically think of all your objects in your game as being in one big long array. The problem is, anytime that you're gonna change that long big array, you're also gonna have to like move the element out into a different thing. And you make changes to that, well, all your jobs that we're currently looking at that list now has a thing missing, and that is gonna cause issues. So you can't you can't make a structural change while you're reading from it.
Cool. There you go. All right. I have another one here from Cameron James Bond. Cool name. What are your thoughts about making a bridge between ECS and the existing physics? Why? To make it very easy to to add small bits of ECS gradually for existing projects, or simply to help learning by allowing non-ECS and ECS control the same physics world? So the question here is basically, what are your thoughts about making a bridge between ECS and the existing physics library, with the idea being that both worlds could work with physics then maybe?
I mean, so I guess the question here is being able to, in your already existing game object game, then having a few things in your dots physics actually interact with the real physics world. And I can't remember what we're allowed to say on the topic, so I'll just say stay tuned on the subject. It is definitely something that people are looking at.
There you go. Fair enough. Okay, and then let's see here. I'm just reading through my backlist of questions. I think we've gotten to a lot of these, and we can move to the next section, which is where we actually got a ton of questions. Actually, one last one here, and I think this one should be pretty simple to answer. Satan Foster, or Satan Foster, I don't know, asked, is there a use case for dots in a complex digital twin simulator?
I mean, that honestly depends again. Like, it depends on what you're making. If you're making a big, like, I don't know, building, construction sort of scenario, architectural situation, that will always cost some amount of performance because you're moving a big structure around, and that's where subscenes could be nice. Do you need it? Probably not. But if you have a profiler, you can tell whether or not it's going to cause an issue. You might, like, if you're planning to show... So I actually, funnily enough, before I joined Unity, I used to work at an architecture firm, making programs that, looked at data from those 3D models. And something that dots could be very useful for there is just, you have your 3D model, you have your architecture, and you might want to show information about, like, how big are the walls, how many walls do I currently have that are of a specific size. And that is something that dots can help you make very easily. And it is a very common scenario in that industry.
Cool. I'll extend your answer to say yes. Yes, it is a good use case.
Sorry. Oh, yeah.
Why not? I don't know. I mean, it's not a bad use case, so
yeah, no. But
there you go. All right. So, given the time, I'm going to kind of merge roadmap and platforms together because we've got a lot of similar questions for both. So we'll just kind of hit both of those at the same time. We'll talk about, the things that are coming up. We'll talk about the things that are currently supported and stuff like that. And so the first actually, it wasn't my first question, but since so many people have asked it in chat here, I can't even name the people who have all asked it, but WebGL support with dots, right? Where are we at with that? Where are we going with that? I don't know if you guys feel like, if you guys are super familiar with that platform.
So it does work. Well, dots is a broad thing. What doesn't work with WebGL, as I understand, is the jobs, right? So ECS works, and you can do like Subscenes streaming and things like that, but you're not going to get burst. You're not going to get the job system, and you also have no entities graphics. So, I mean, I guess when I say works, there are limits, but you can get some value if you want to just use ECS in your code as normal ECS. Yeah, you can do that.
Cool. And correct me if I'm wrong, but it's really often a limitation of the browsers, right? The browsers don't give you access to multiple cores. They don't give you access to so many of these pieces, and therefore, that's the biggest limitation. We can't control the platform. We can't control what a browser will and won't support, which is ultimately what makes it very challenging to add in all the goodness of dots.
Yeah. Supposedly, web GPU should also help with some of this, but we'll have to see.
Yeah, and you're exactly right, and Daniel's right as well. There's technology coming to WebGL that, like, Unity's, as I understand, we're just like waiting. We're waiting for the spec to catch up so that this modern technology can work on it.
And we also have web GPU, for instance. We already have demos up that people can try if they want. to see some of this already working in newer browsers that are very beta right now. I think it's specific versions of Chrome only.
Yeah, exactly. Yeah, I know that's not the greatest news. I know a lot of folks in here are like, yeah, we do WebGL stuff, a lot of WebGL stuff, and it's like, I want it too, right? So yes, in the WebGPU stuff, obviously we can't talk too much about that yet, but has some exciting potential and some possibilities there. Cool. All right. So then the next thing we get asked all the time is animation with Dots. When is Dots going to support animation? Because that's obviously a very important thing for people that are making games.
So you can technically use Mechanim, right? You can mix game objects, you can mix ECS. So there's no reason you can't have a game object that's animated using Mechanim and you run simulation code in ECS. Now, that is not ideal, obviously. And so the question is definitely asking more like, when can this just be all ECS? And that is more of a roadmap question for like our animation guys. But I would cheekily invert the question. It's not when will Dots support animation, it's when will animation support Dots.
Shots fired.
Yes, definitely. But I mean, it's on the, like, internally it is there and it's coming and it's being worked on. It's not like a one day maybe we'll do this. No, it's heavily actively developed.
Yes.
Exactly.
Yeah, and as we say, we are planning on making the whole game objects entities story nicer to work together, and just by having those two bridged nicer together, that story is also already made simpler.
There you go. Yeah. I do want to call out and reiterate though, sort of in the meantime, not the greatest scenario, but yeah, you often, because someone else in chat here, Bob asked about particles working with ECS, and there are some components that in some workflows that just don't work with ECS yet, right? It's just kind of the nature of it. So, a lot of times what we'll do is we'll use an entity to drive a dummy game object, which is the visuals that has like the animation on it or the particles on it or whatever. Kind of almost like the companion objects we were talking about, or companion things we were talking about earlier, is where you'll just drive game objects that they don't really have any logic on themselves. They are just the animation, just the visual piece, right? Because again, the visuals is just the display, right? It doesn't mean that's where the logic has to live or anything like that. Almost like an MVC kind of setup or whatever, where you can separate out the logic from what you're actually seeing. Yeah.
I think for anyone who's hearing this and thinking like, oh, is that tricky? Like, how well does that work? Like, the game I love, go on Steam, type in V Rising. If you haven't heard of it, it's fantastic. It's an ECS game, and when you play it, you will find animating characters, particle effects, sounds, right? Unity isn't game objects or ECS, it's Unity. They made a game with Unity and they used ECS and they used everything else. So it's actually very doable.
Yeah, and also another thing to note here, the thing that is not currently supported is playing back animations. And because Dots is so customizable, a lot of people have also just made their own implementations. We already support skinned meshes, and all the bones will be there and baked properly. Our baking systems does all the correct things. So all you really need to do is have something that moves those bones around. That is what we currently don't have. And so you see people online. There are asset store packages that will do this. There are different tools online that will help you do stuff like vertex animation, where you have just one texture be all of your animation, and that's very fast. For, there's a game called Totally Accurate Battle Simulator that is a huge army, all animated. And this sort of style of animation is actually really expensive to do the normal way. And that's actually where it's useful to have this customizability. So it's not that we don't have the possibility of someone making their own. Just wanted to add that as well.
There you go. So yeah, again, through programming, all things are possible. There are third-party solutions you can make your own, and we are working on ours. So it's one of those, like, stay tuned. But yeah, companion objects are definitely the way I make this work right now, personally. So, okay. So the next question here is actually a few different people have had similar versions of this question. And so we've got Hyper has asked this, and also Prime Gaming Axe Megas, cool name, is basically asking about like generating large meshes, procedural meshes, specifically for terrain, or when can we expect some procedural tools for large world building in ECS? So basically, using ECS or using dots to build big landscapes, big worlds, big meshes procedurally.
Well, I noticed there was a when in there.
When slash how slash
yeah,
can you,
yeah.
slash, whatever. Answer how you feel comfortable.
There are more things coming that give you more out-of-the-box tools for some of that. I'd also say like burst and jobs, not ECS, but burst and jobs. You can do quite a lot of cool procedural stuff, make use of your cores. There's a more modern mesh API than Unity ever used to have that's out there, lets you upload vertices and things like that. So you can do a lot of that today, and I've seen asset store projects and people do this. So we've got tools coming. You can do a lot with burst and jobs yourself. And then regarding entities, like Subscenes let you build and edit and stream large worlds. That's a big part of that. But I highly recommend you check out Stunlock's V-Rising presentation on how they did the editing for their world, because they are heavily using entities to optimize the editing experience of the Unity scene editing, so that they can like manage and edit huge numbers of objects. And it really enables them in ways that normal game objects wouldn't.
Yeah. Again, it's about that point that because all of this is, for the most part, written in C#, you actually have access to the source, and therefore it enables so much customizability.
By the way, we actually have a Creator Spotlight live stream that is recorded on our YouTube channel with Stunlock Studios about V-Rising. So definitely check it out. Unfortunately, I don't have a link for you because I was not expecting this to come up, but it's in there. If you search for it, there's a dot segment. So yeah, be sure to check that out. Okay, so just a few more here. We're coming up on time. This one we got early on, so early that I forgot to write down who asked it, so apologies. But I have a game made in Unity 2017. Can I integrate dots?
Was there a version?
Don't laugh, Daniel. That's a real question.
That's a very. I don't know that there was a version of ECS available in 2017 Unity.
Maybe jobs?
Didn't we demo it in 2017 at Unite? So it was near the end of the year, but it wasn't something that was publicly available.
Yeah. I think it's unlikely. I wouldn't.
Yeah.
I wouldn't count on that necessarily.
Hopefully you can either upgrade the project or see other ways to do it.
But I do know Burst is in 2018. So if that's not too big of a jump from 2017 to 2018 for you, then Burst can be unlocked.
There you go. Unless you want to backport it. No, I'm joking. Don't.
I'm not on the Burst team. Why not? Yeah.
Yeah. Why? Through programming, all things are possible.
Great.
I mean, there's no reason you can't. I'm just saying.
It's technically true.
Yeah, it is. Technically true is the best kind of true. Then, well, actually, this question we already answered here about WebGL. Oh, last one here then. 2D games. Support for 2D has come up a few times in the chat, a few times last week as well. Where do we stand on that? Because, Daniel, you just showed a scene a little bit ago that was 2D, but I don't think officially, technically, we support 2D, but it kind of works because you can turn sprites into entities. So, like, where do we stand on that?
So currently, for sprite renderers themselves, they will be a companion object. So there's no real support for it. The thing that I did for my project, because I needed a lot of 2D objects, is I use just quads and move the offsets around, causing all of the animation to work and everything. And it only took, a game jam to do it. That amount of code, right? The actual way, I've seen an asset called InSprite, and I can definitely recommend also using that one. It allows for a lot of 2D animation to happen. What we have currently, that is it. What we have in the future, we'll see.
And can you speak at all about the state of physics in that regard?
There's none. But you can obviously use the 3D physics and just make sure that you only move along one plane.
Just lock the z-axis, right?
Yeah, exactly. Yeah, and the physics is stable enough to do that. So it's
the answer is never no. The answer is it depends.
Yeah.
Yes.
Well. Also, I feel like just to iterate it, like it depends. Sometimes means it's gonna take a while, and you have to do a lot of stuff. If for the case of 2D, it's something that you can for the most part do in one day, if you know ECS. Like drawing a quad is so extremely easy. Moving an offset around is also fairly easy.
Yeah, I think we often keep saying, like, there's often a question of, is this supported? And sometimes we say yes, sometimes we say no. But not supported doesn't mean you cannot do this. Like what Daniel is describing there is something where we would say not supported. But actually, you could very easily do that. And as he said, he did it in a day. So there's actually no barriers there to doing this stuff. The Unity is available to you. What isn't supported is there's not a iComponent data type for an entity that is like a sprite renderer, and it will be an entity only, and there's no game object. That is what's not supported. But 2D with ECS is definitely possible.
Yeah. And actually, to the people that are curious, also I noticed in chat, people are saying, "Oh, well, claiming to the Z-axis is actually fairly difficult." I can say that on Friday, I'm actually going to talk about the 2D project with Johnny, and we'll go over how to do that very soon.
So you're holding back on us. You're holding the good answers for your stream with Johnny?
Well,
are you kidding me?
Look at that plug straight away.
Oh my god.
It's only the third time this stream, right? So.
Also, he has a book coming out on the 31st. No.
That's right.
I think I did help with the ebook. So
didn't your new clothing line just launch? Is there something you want to plug there? Like...
Oh.
Okay, well, if you're interested in 2D stuff, that's right. If you're interested in 2D stuff, check out the stream with Johnny on Friday. So there you go. By the way, Stay Thirsty 90 says that all his homies hate the Z-axis. So there you go. Stay thirsty. Appreciate that. All right. I think we got to most of the questions. I know we're at time. There's probably more questions. I highly encourage everyone, if you have more questions, come to the Unity forums, ask more questions. This is where a lot of these questions came from to begin with. We can always schedule more of these. We just collect the questions, we build up, and we do more. So let us know how it went. Let us know what your thoughts are. We can start wrapping up here. Let's see that slide or that image that has all the things that you should look out for, and then let's post those links again in the chat, if you will, please, moderator folks behind the scenes, so that we can kind of close things out here. Maybe.
I'll also plug, come to the Discord. We interact quite a lot with people on there. We have a dots thread that's very active.
Yes. I don't know why I didn't say Discord as well. And discussions too, which is where you can ask a lot of questions and things. We have so many places. So definitely come and engage with us. Links are flooding the chat now. And a reminder too, next week is our Asset Store and Odin live stream on that Tuesday at 12 Eastern. And then on May 1st, Unity Cloud Services. We're going to run through a lot of those cool things again on May 1st at noon Eastern. Otherwise, awesome. Thank you all very much. Thanks to the chat for participating. By the way, Twitch, YouTube Live. I mean, you picked up, but they kicked your butts here. We're gonna work on this. We're gonna work on more engagement on Twitch here. But thank you all so much for the conversation and the chats and the questions. Christopher, awesome. Thank you, Daniel. Awesome. Thank you very much. Any last words? Any parting bits of wisdom besides Daniel plugging his live stream?
Well, I only
again?
did it to save time, I will say. But sure, we can say I plugged everything.
I'll just plug Future Dots again. Like, we have such cool stuff coming. You can't even imagine. Like, I can't wait to talk about it one day.
Yeah.
It's so good. So please look out for it.
Actually, on that note, for anyone here in the chat who's watching along, who is a Unity game dev, actually making something and wanting to test out some animation stuff, email me, mike@unity.com. We're looking for some testers on the down low. So just for the folks who watch this, feel free to message me. But awesome. Well, again, thank you very much. Yeah, exactly. Secret. Thank you very much, everybody. Really appreciate it, and can't wait to see you all next week. So, for now, cheers and take care.
Bye bye.